Hi everybody, this is Andrew, and today we'll be doing a tutorial on how to create a voxel explosion effect. So here is an example from the game Under Over. So the bird's flying along, and when it strikes the Torii gate, it blows up into a explosion of particles. Just one more time. So there. Okay, so let's close that. First of all, we need to open up Unity. Now I'm using Unity 5.5. This is the personal edition for this tutorial. So let's create a new project. We'll just call it Voxel Explosion. Make sure it's 3D. That's all. Create project. Okay. This is a little bit targeting beginners, so excuse me if I'm talking a little bit too detailed about some things. So first thing we want to do is create a scene. Well, we're going to save a scene. So let's create a folder called Scenes, surprisingly. And then we can save this so just Control S in Scenes, and we'll call this scene anything you like. Let's call it Main. The main scene. Okay, so we've saved the scene. Now in this scene, so we'll go to Scene View. In this scene, we'd like, we'll keep it in orthographic view. We want to create a plane, or some ground for our player to fly over. So let's do that. The ground can just be a cube. We'll just change its dimensions. So there's a cube. It's positioned at 0, 0, 0. Now we want to scale it. Let's scale it to 40 along the X and 40 along the Z. So we have a large plane, as you can see there. Now to rotate, all I'm doing to rotate is holding Alt and the left mouse button, and I can scroll around like that. If I hold Control Alt mouse button, I can move, I can pan the screen. Okay, so Alt and left mouse button to do what I'm doing there. Now the color's not very nice, so let's make a materials folder. Materials, create folder. We'll call that materials. And inside our materials folder, we just want to create a, surprise, surprise, material. We'll call that ground. Now the ground material can simply be, well, we'll keep the standard shader. I mean, I don't want to get too complicated, involved with what shaders do and all that, but basically we'll just keep the standard shader. There's a whole bunch of other ones. And for mobile development, you'll probably want to use something a bit less, something other than the standard shader. Actually, to keep it simple, let's go to Legacy Shaders, and we'll go to a Diffuse Shader. So it's just a very simple shader that gives us color, basically. So let's change the color of the ground to something, what color is it? Let's make it some grass, so a yellowy green color. That'll do. Right, so we've got a ground material. Now, this is our ground here, so let's rename it to ground, and all we have to do is drag the material onto the ground, and we have a nice, well, some might call it nice, green ground. And if we go to our game view, that's what the game will see. Next, we want to create our, I'll go back to the scene view. Next, we want to create our player. So our player, actually, let's make a player with multiple colors. Now in order to do that, we'll have to use a program, well, the program that I recommend to use is called MagicaVoxel. So MagicaVoxel is available for free. It's a very good program for making 3D voxel models. It's available from this website. Anyway, I'll put that in a link somewhere so you can download that. So I'll open that up. And this is the MagicaVoxel main screen. I'm going to make our cube. So here's the default cube. I don't really want that. I'm going to erase that. One way we can erase it all at once is just go to Tool, 0. So there we go. We're left with just an empty thing. And I'm going to resize all this. Instead of 40 by 40 by 40, I just want a 20 by 20 by 20 cube. There we go. To make a cube, we just go Attach. We'll choose white to begin with. Again, we can pan by using, in this case we have to use the middle mouse button. And I'll create a flat plane, and to give it to make it solid, to make it a cube, I can just go to the face mode here. So face mode, and then I can just build it up. Now the cube, it's a bit plain looking. Just to make it a bit easier for us to work with, I'm just going to turn on grid and frame, and I might set the frame to 5 so we can see divides it up nicely for us. Now the colors, let's just make some random colors. To color the cube, we can just use the paint tool here. So let's give it, oops, I'm still on face mode. Let's change it to B. What does B stand for? Box mode. Anyway, it's your standard mode. Let's paint that to be red. Let's use yellow. The next section can be yellow. And the next section can be blue. And the final section can be green. Choose any green you like, it doesn't matter. This is just an example player. You could make a bird, you can make a rocket, whatever you like. Just to quickly show you a couple of other features of MagicaVoxel, we can erase some parts. So for example, if I didn't like this corner, I could erase that. Just say I wanted to erase every corner. Well, I could do it this way, but it would be quite slow. So instead, I'll undo that. I'll just use the mirror command, the mirror option here. So you can mirror in the X, Y, and Z axis, and that will hopefully, that removes all the corners. So yeah, that's our player to say. So we'll save that. I'll just save it on the desktop. We'll call it player. Now to export to Unity, we need, well, there's a few ways we can do it, but we'll be doing it by exporting it as an OBJ file, an object file. So before we do this though, we need to make sure that the pivot point, now I know this is probably a bit complicated and don't really need to know, but it gave me a lot of trouble when the pivot point wasn't in the center of this model. So to fix that up, I think by default MagicaVoxel doesn't center the pivot point. We need to go to, let's open the File Explorer. Go to the MagicaVoxel folder. So that should be in your program files, MagicaVoxel, and go to config. Now in config there's a config.txt file. Open that up, and I've already got highlighted here. See, there's a file object, and it's only a small file. Anyway, go down to File OBJ, and change the pivot. I think it defaults to that 0.5.50. Change it to that 0.5.5.5. Save that. Go back to MagicaVoxel. I'm not sure if we need to. Anyway, you may need to restart MagicaVoxel. Let's just do that. Let's just restart it. So if we go back to the desktop, and I'll just open up my player. Yeah, so that config file will definitely have taken effect. There's our funny looking player. Now go to Export Object, and then we'll export it to Unity. So we need to find our we need to find that project file. So wherever your Unity project is saved, so in mine it's current projects, go to Voxel Explosion, Assets. Let's make a new folder called Models. It's just to keep everything tidy, otherwise you'll have files everywhere and it'll be very hard to find stuff. So we'll go to Models, inside Models, yep, player.obj, save that. We can probably don't need that anymore, so we'll just minimize that. In Unity, if you look under our Models section, we should, okay, they've created a Materials folder because the model requires a material. So the red, yellow, blue and green is using this palette. Doesn't matter, it's just a small file that MagicaVoxel exports to use its own material. Anyway, so we have this model now, we've got this player model. There's got lots of files associated with object files, all the rest of it. You don't really need to know much about that. I mean, you can go in there and edit stuff and change its palette and so on, but we won't do that now. Okay, so we've got the player. Let's just drag that. Let's drag that model onto our scene. Whoa, it's quite huge, isn't it? Now, that's way too big. If that's a 40 by 40 meter or whatever, 45 by 40 unit plane, well, our player is too big. So just undo that. You'll see when you click on this model, it's got a scale factor. Now in MagicaVoxel, can you see that we've made a 20 by 20 by 20 cube? Now each one of those units automatically relates to one unit in Unity. So what we want to do, well, depending on how big we want our player to be, just say we want our player to be 1 meter or 1 unit in Unity. Well, we need to make it 1/20th the size, don't we? So 1/20th of 1 is 0.05. You can work on the maths yourself. So we'll change that to the scale factor. We'll change the scale factor to 1/20th. Now, if we drag that on there, yeah, it looks still big, but we haven't applied the scale. So we'll apply that now. There we go. We have ourselves. You can just double click on any game object to zoom into it. Remember, Alt left to rotate. So there's our player. So we can move him in the Z and X direction. Now, where do we want this player to be? Well, let's see where our camera is. Our camera is there. Remembering we can move our camera. So I'll move our camera. Let's move our player first. We'll move our player to over here. It's above the ground. And then we want to make sure our camera is in a position that can see. Yeah, our camera angle is not very good, not for an isometric game. So I'm going to set some rotation here. It doesn't matter what rotation, you can change this to however you like. But I'm going to set it to 35-45. That's what I use in under/over. And we'll change the projection to orthographic. Right? And we'll make sure that it's probably, in our game view, we can see that it's probably a bit too large a view. So we'll change that to size 4. So this is in the camera. Look at the game. Yeah, that looks a bit better. And we'll make sure that we can't see the edge of the land. So we'll just move that. See the camera preview down the corner there. You can move that. There we go. Now, see that the player is clipping there? That's probably because our camera is too close. So I'm going to raise the camera a little bit and just move it. There we go. It's a bit further away now. So we'll move it back into position so it's not seeing the edge of the ground. And we'll move our player so that it's in a nice position. We'll make it a bit lower. There we go. You can tinker with this however you want. It's not that important. It's just for aesthetic reasons, really, isn't it? Okay, that looks like a good position. Right. So if we hit play, nothing much happens. We see our cube, and it's not doing anything. That's fine. I might just rotate that player. I'll rotate it 90 degrees. Zoom up to it a bit. Yeah, that looks a bit better. Right, now the next thing we want in this view is that we want something for it to collide with, don't we? So let's make a wall. So we can create, a wall's just going to be a cube as well, so let's create a new 3D cube. We want it to be at the other end, and we want it to be much bigger. So it's going to have some height to it. Let's give it 5 height, and it's going to have some, is it Z or what X I should be using here? Oh, yep. Let's say it's 20, 20 wide. It just happened to be in the, happened to be right on the ground there. But if it isn't, so can you see that it's within the, I'll change that to wall. Wall. Double click on that. If it happens to be in the grass or whatever, you can adjust it just using the arrows here. Make sure that you set, if you look up here, this is the, like, that's rotate, that's whatever, that's some other sort of thing. Use this one here so that you can move it in X, Y, Z direction. Okay. Now, just a bit of a hint, if you want to be flush with the ground, you can use V. V means the snapping tool. I don't know why they used V, probably one of the free keys, but you can go Shift V to get it into snapping mode, Shift V, and see it will snap to one of the corners. Now I want to grab that corner, snap it to the ground, that's okay. Turn off snipping mode with Shift V again. Now it's flush with the ground now, and then I can just move it into position. So I'll zoom back. Well, that's about right. We can have it close to the player if we want to. We probably want a different color, so let's go to our materials folder. Duplicate the ground just by going Control D, because we want everything to be the same except the color, and change that to wall. And choose a color that you want for your wall. So what color will we have? Maybe an earthen sort of brown color. That'll do. Doesn't matter, you can make it however you wish. Okay, once you've got that, drag the material onto the wall, and now we have a bit of a, I can't see it in that view, but you can see that there's a wall in front of the player. If we hit play, again, nothing will happen. So what we want to do is for our player to travel. If you see when I'm dragging him towards the wall, the Z number is changing. So we want to change that, don't we? We'll keep it at about 14. It doesn't matter where. So we want to change the player in the Z direction. We want to move him. Now, how do we move something? Well, it's simple. It's not really simple, but you need to do anything to any object, you need a script. So let's create a script folder to store all our scripts. Now, in today's tutorial, I'll be using C# because I normally use C#, but you can use other languages if you wish. So in the scripts folder, create a C# script. You can also use JavaScript if you wish. C# script, and we'll call that player control. You can name it however you wish, but for this purpose I'm going to call it player control. Double click on that. It should open in Mono Develop, which is just the default C# editor. Now all scripts in Unity that have mono behavior will have a start function and an update function. As you can see here, use this for initialization. So anything that you want to initialize, put it in here. That'll only be called once. It'll be called once when the object is created. An update will be called every frame. So this is where we want to do our movement in here. Okay, so knowing that our player will have this, we can just go transform, position. So that's the location in space, and all we're going to do is add to it. So plus equals, if you know your coding, it'll just add to it. Plus equals, now we want to go in a forward direction, so we'll go vector 3, so the Z direction is a forward direction. Vector 3 forward, just to confirm, see it says here, shorthand for writing 0, 0, 1. So x, y, z, 0, 0, 1, it'll go 1 in the forward direction, the z direction. Now we want to times that by the delta time. So if you know about frame rates and all that, delta time, here it is, the time in seconds it took to complete the last frame. So it's it's a fraction of a second. So whatever that might be, it might be 1 in 30 or 1 in 60. And we want to times that by some arbitrary value. We'll call that speed. So you can set that speed. We'll set it as a constant up here. So we'll call it a constant. It's a float, and we'll call it, it's called speed, and we'll say it equals, let's try 1. You don't need the f, but it's good practice to say that it's a float, 1f, 1 float. Okay, so it should move every update, so every frame it should move a fraction in the z direction. Now speed will just mean how many units it goes per second. So how many game units does it go per second? So it should be going 1 meter per second. Let's try it. Remember, well, maybe you don't know, but in order for this to work, we need to put this script on the player object. So just drag it onto the player object. Now you click on the player object, you can see that now it has a player control script. Great. Let's run it, see what happens. Okay, it's moving, but very slowly. So let's up that speed to say 3. You could make this a public variable, and then we'll have access to it outside of here, but let's just keep it as a constant. So call it 3. How does that play out? That's a bit better. So 3 is quite speedy. I'm sure one question you're asking is, hang on, the camera is not moving. It's not, the player's just zooming off screen and we're still stuck looking at the ground. Not very interesting. So that would mean we have to move the camera with the player. In order to do that, you guessed it, we have to create another script. So let's create another C# script. Well, this time we'll call it cameraCtrl, just to keep with our consistency. cameraCtrl. Okay. Let's immediately wire it up to the camera, main camera. Double click on that. Now what do we want the camera to do? Well, first of all, we want it to move, but we want it really to follow the player. Now in order to do that, we probably need a player object. So let's make a public variable. It's going to be a game object because most objects are game objects. Public game object called player. And we want, in the update method, we want the camera's position to match the player's position, or keep up with it at least. So in order to do that, we'll say that transform position, so this is the camera, remember this is in relation to the transform relates to the camera in this case. Transform position will equal, let's create a new vector 3. So every frame it's going to create a new vector 3. Now we want it to be equal to the player's position. So we just go player, transform. Now remember it's X, Y, Z, so we want it to be position X. Rather than typing this every time, I'm going to just cut and paste, cut and copy and paste, sorry. Player transform position Y, so X will stay the same, Y will stay the same. The only thing that's going to be different is the Z. We'll go into a new line. So player position Z. Sorry, I've stuffed up there. I don't want the X to follow the player. The X will just stay the same for the camera. The Y will stay the same for the camera. The only thing that will be changing will be the Z. So it will be following the player's Z position, or Z, wherever you're from. Okay, let's try that. I mean, a lot of programming is just experimentation. So I'm only experimenting here because I can't 100% remember everything. So let's play that, see what happens. okay, we've got an error. It's good to have errors because it tells us what's going wrong. It says unassigned reference error. The variable player at camera control has not been assigned. Cool. So go to your player, not player, sorry. Go to your camera. Now down the bottom there's our camera control. See that because I had a public variable, that's not it. See, I've got a public variable called player. That means we need to assign something to that variable. So under the camera, under camera control, there's a player. So all we have to do is drag our player object onto there. And that should be okay. Save it. Let's play, see what happens. Right. Not perfect, but the player is moving as well as the camera. A couple of issues I see. It's a bit shaky. Now I know the problem. I know why that's happening. It's because, well, I've read enough tutorials to know that camera controls should generally be updated in the late update method. So late update is called after all other updates have occurred. Late update is called after all other updates have occurred. Now, let's just quickly look at that. It should be less jumpy, hopefully. Yeah, it seems pretty smooth now. But the other issue is that the camera's jumped, hasn't it? It's jumped so that it's not really focusing, like the position we want. Oops, I've paused it. The position we want is that, so the player's kind of centered or whatever. We can adjust the player position. So let's move that back a bit. So ideally, let's say there. Let's say we like it there. Okay, great. So to keep the camera fixed, we need to calculate. So let's make a private variable called, it's a vector3. It's all to do with position. We'll call that difference. Now in our start method, remember start's called just once. We're going to say difference is equal to, what's it equal to? It'll be equal to the transform, so that's the position of the camera minus the position of the player. That's all it is. So we've got this thing called difference at the start. It calculates how far is the camera from the player. And then we want to use that difference to keep the Z position consistent. Now, X and Y we don't need to worry about because they're not changing, but Z is. So I'll put that onto a new line. Player transform position.Z minus the difference. Now I'm just a little bit bit of guesswork here. Dot Z. We'll just experiment, see what happens. So the Z position of the player minus the difference Z. Okay, let's try that. How does that look? If it looks stupid, we'll just do it again. Yeah, that's not right. Maybe I should be adding it rather than subtracting it. Let's try that. That looks better. Let's try that again. Yeah, so you can see that it's kept the relative position of the camera to the player and it's following it. Let's try that one more time. Yeah, that's looking good. Okay. The next step is to add collision detection. Currently, when we hit play, the player flies along and just passes right through the wall. Not exactly what we want. So in order to allow collision, we need to add something called a collider. So all objects will require one that we want to interact with. So the wall, it already has a collider because it's based off a 3D cube. So if we zoom in, you can see that green outline, that's the collider. We can turn it on and off, leave it on. And the player will also require a collider. So let's type in box collider. There we go, you can see the collider there. It's the green outline. It doesn't really matter that the box collider is going over that sort of corner where the model seems to be, the model is missing its corners, but it doesn't really matter for the game effect. So we'll leave it like it is. If we play that, you'll see that nothing happens. We've both got colliders, but yeah, nothing's happened. The reason is that one of those objects must have a rigid body. Now that's just a Unity rule. So we'll give our player a rigid body. And here's the rigid body here. As you can see, it's got mass, drag, and so on. Currently use gravity is checked. Let's see what that does. Yeah, it makes the object fall to the ground and slide along. But luckily it strikes the wall, which is good. So let's turn off gravity. I want the objects to fly. Turn off gravity. The next thing we need to do is identify what the player has hit. So in order to do that, we need to use something called tags. So the wall, there it is currently untagged. So we can add a new tag. We'll call it wall. I'm using all caps so that I can recognize that it's something that I've created. So go to wall. So here's all the default ones, but here's the one I just made down the bottom. So let's make it a wall. And we can detect that wall by going into the player control method. So let's open that up. Edit script. And using an inbuilt method called onCollisionEnter. Now it takes a collider, I think. No, it takes a collision as a parameter. We'll call that parameter other, because it represents the object that it's striking, so the other object it's striking. Let's use a condition. So if the others tag, the other game object tag equals wall, we can do something. Now it's good practice not to hard code all these things in your classes, so it's probably best to make that a constant. Now you can put these constants anywhere. You can make a global file that's used by all your scripts. So we'll just make it a private constant. Private constant string. It's called wall. No, it's not. Let's call it a tag. Tag wall equals that. Therefore, it's much less likely that we'll make typing errors throughout our scripts. So yeah, if we just go tag wall, it's a bit more, it's a better standard, I guess, to use. Okay, so if the other game object tag equals wall, let's do something. What do we want to do? Well, we want to explode the player, don't we? So how about we just make a function called explode. Doesn't exist yet. Let's make it. It's going to be a private void explode. Let's do something just for the time being. We'll put a to do there. To do explode the player. To make sure that's working, let's put a debug. So debug log. Oops. What will we write? Just explode. That'll do. So we can check to see that this explode function is being called. Go back to Unity, hit play. Okay, it's flying along. What happens? Bang. We can see down here, explode. So yeah, we know that it's all wired up correctly. Great. In order to add the explosion, we want to create something called a particle system. So if you just right click here, here it is here, particle system, click on that. And all a particle system is it fires out a whole bunch of particles. Now, at the moment that's not really what we want. They're kind of like ghostly in a way, aren't they? So we want to make it a bit more solid, and we don't want them flying out like flying upwards like that either. Okay, so look at these parameters here. 5 seconds duration is probably quite good. Looping, we don't really want it to be looping because we just want a single burst of particles when the player strikes the wall. Lifetime speed, yeah, that all looks fine. Start color, whatever. Play on awake. Max particles, we don't want 1,000. Let's change that to 50. Okay, emission, we don't want it to emit. Emit means it's doing something over time. We don't want that to happen. So we'll turn that to 0, and instead we'll have a burst. So here's burst, hit the little plus symbol, and we'll have a burst of 50. So if I hit simulate, bang. Again, it's firing upwards, not exactly what we want, but a burst of 50 sounds about good, I think. The shape, currently that's a cone going upwards, don't really like that, so we'll go with sphere. Let's see what that looks like. Yeah, that looks better, firing out in all directions. Yep, stop you. Radius 1, yeah, that's all fine. Randomized direction, yeah, it doesn't really matter. You can tinker with all these parameters as you see fit. The next thing we want to do is phone. The next thing we want to do now is modify the renderer. Currently the particles are shooting outwards and they look kind of ghostly in appearance. So on the renderer section, change the render mode to mesh. The default particle looks like a bubble or something, so we don't want that. And we need to give it a new material. So in your materials folder, just duplicate wall, so Control D, and we're going to call the new one explosion. Choose a color that you like. It doesn't matter because we'll be modifying the colors at runtime. I'll just make this one orangey. Go to the particle system, down to renderer. Oops. Renderer. And just drag that new material onto, there we go. So as you can see, these huge cubes are flying out of the player. Not exactly what we want. So let's first modify the size. Size. Probably 1/10 of that, so 0.1. Try that. Yeah, that looks okay. But we don't want the particles to fly off into space because, well, there's gravity, isn't there? Let's apply some gravity. Gravity modifier 1. Okay, it's starting to look a bit better. Another thing we should do is currently the particles are just falling through the grass. So to make them interact with the grass, we should add some collision. So just go down to collision, click on that. Yeah. Now it might be set to planes. If it's set to planes, just change it to world. Wow, they're bouncing quite high. It doesn't look very natural. Looks like the grass is made of rubber or something. So we'll get rid of the bounce. We'll cut it severely, 0.1. That doesn't look very good either. Tinker with these however you see fit. Maybe 0.5 might be okay. Yeah, that looks alright. Have we got looping on? We haven't got looping. Yes, we'll turn looping off so it just does it once. It'll go bang, particles fly out, go everywhere. Maybe the speed's a little bit too high, so we could reduce the speed. What does 1 speed look like? Simulate. Almost there, isn't it? Try 2. Yeah, that'll do. We'll just keep it at 2. So start speed 2. What else do we need to do? Is it interacting well with the grass? Yeah. Sliding along. Righto, that looks okay. Next, back in our script, so there's our particle system. In our script, we'll need to instantiate this particle system. In order to do that, we should make a prefab of this system. So create a folder called prefabs, and within that folder, create a new prefab. We'll call it explosion. Now all you have to do is drag the particle system onto that prefab. You can zero out the position if you want to. It doesn't matter. The position will be set from within our script, and we no longer need this object now. This object was just there for us to create the particle system. So I'll delete that. But we have a prefab called explosion. Back in our script, we'll need some way to access that prefab. So let's make a public game object. That should do it. Call it what you like, but if you want to call it prefab, you can. Prefab explosion. And we can link that up in Unity by going to player script, and here it is here, prefab explosion. So just drag the explosion into there. Good. And then in our explode method, we can instantiate. We'll get rid of all that, we don't need that anymore. We can instantiate, a fancy name for create, instantiate the object, so it's going to be a prefab explosion, and now we have to give it a transform, so basically a position. Now we want the position to be the same as the player. Okay, so we can just go transform, which represents because we're in the player control script, the transform does represent the player transform. That should be okay. Game object, original, yep, transform parent. That should be okay. Let's see what that does. So the player's flying along, hits the wall, and oh, there's a few particles there. Not exactly what we want, is it? Wonder why. It's like the particles going off in the wall. I'll see what's happening in the scene view. Try again. What happens in the scene view? Yeah, it's not exactly lining up with the player, so we just need to do a bit of tinkering there. Prefab explosion transform. It looks like I've probably used the wrong. I've just tried a couple of things. It looks like I've used the wrong method here. Instantiate. I should probably use the position. Here we go. So there's an instantiate method which has the original. So that's the explosion. The vector3 position, that's what I'm interested in. I'm interested in the position of the player. So we'll use transform.position, and then the rotation. So I wonder if we can not use the rotation. Oh no, I think we have to. Yep. So the rotation is just the rotation of the player, so we can just go transform.rotation. So it'll match the same rotation of the player as the player. Let's give that a whirl. Okay, strike the wall. Ah, that's better. And a whole bunch of particles come out. As you can see, they're kind of within the player, which isn't very good. But what we should really be doing is destroying the player. The player shouldn't exist at this point in time. Bang. Yep. So yeah, some particles floating about in the player, but we'll destroy the player. So back to our, I'll close that. Back to our script. So we'll instantiate the explosion and we'll destroy the player. So that's just the game object. I think destroy takes a game object as a parameter. Yep. Or takes an object. What does that do? Hopefully the player disappears. Flying, flying, flying. Bang. Okay, great. The player's destroyed into 50 pieces. Oh, we got an error here. The object type game object has been destroyed, but you are still trying to access it. Ah. It says your script should either check if it is null, or you should not destroy the object. Well, I'm sorry, I don't want it anymore. What would be trying to access it, do you think? Destroy the game object. Yeah, we don't want to destroy the game object, so remove that line. As a workaround, what we should do is create a parent object here. So just go create empty. We'll call that player. And this, our existing player, we'll call that the object. The object player. That'll do. Now we want the script to be run, and that's a child of player. We want the script to be run not on here, but on the player object. Sorry, it's confusing, I know. On the parent. So let's remove the player script here. Remove component. And we'll put the player control script here. Player control script there. I'll just do that again because it didn't do it it did it quite quickly. So yeah, you can just do a search for the name of the script, so player control. Add that, add our prefab, the explosion, great. And we also want the rigid body on there, so let's remove the rigid body from here. Remove component. It can keep the box collider, that's fine. The rigid body will be here. So let's add that, add rigid body. And that looks all okay. Except for the gravity, we don't want that. And we want to access this object. We basically want to destroy this object within the script. So if we destroy this object, it's not going to destroy the script. The script will still be running here happily. But we do want to destroy the actual model, I guess. You could technically just turn off the model, that would be okay too. But let's destroy it. Object player, we want to pass that to our script. So let's go up here, object player, wire that up. So now it's looking for another parameter. Stick that in, object player. And in our script, let's destroy that. So when an explosion occurs, we want to destroy the player object. And hopefully that'll do exactly what we want it to do without causing an error. Great, but it's still causing an error. The The object type has been destroyed, but you're still trying to access it. Am I? Right, so the error is I'm still trying to access the game object. And it turns out I'm trying to access it in the camera control script, because actually we're referring to the player here, aren't we? So we can fix that up by going to, let's stop this. Let's go to the main camera. It's referring to the object which we've just destroyed. So what we want to refer to instead is the parent. Right, so the object player, obj player, is going to be destroyed in script. That's fine. And the player is the parent as such is still going to remain, so that the camera has something to focus on, which we want. It's still going to focus on something. If we destroyed the entire player object, then the camera is missing its target as such. So let's try that. Okay. Smash. Oh. Yes. Well, clearly we don't want to continue moving the parent that way, do we? We want to stop the parent, so we can do that easily enough. So when it explodes, we're going to destroy the object player, and we do not want this update to occur. So how can we handle that? The first thing that comes to mind is probably having a flag. So let's do that, a boolean. So we'll have a private bool, just called exploding. So on start, well, we're not exploding when we start, are we? So you don't need to set this, but it's just, I guess, a good practice. Exploding equals false. So we're not exploding when we start. But when we explode, obviously, we want to set that flag. Exploding equals true. So when we explode, yes, exploding equals true. We destroy the object, the player object, and we instantiate an explosion. And in this update method, we don't want to continue moving anymore. So if it's exploding, if it's not exploding, we want to perform that transition. We want to move forward. So therefore, when it explodes, this will not occur. We'll just stay where we are. Let's have a look. Fly, 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 smash. Millions of pieces. Well, 50 pieces. Righto. In order to color the individual particles, we need to grab them from the particle system. Now we have to do all of this in a late update. We have to do this in a late update call. So late update. If you do it in the regular update, as far as I know, it simply will not work. So remember, late update gets called after all other updates. So if exploding, we only want this to occur if it's exploding. Let's first get the particle system. So particle system, explosion, we'll call it explosion system. I don't want to call it system because system's often used to refer to system components. So let's call it explosion system. Particle system, explosion system will equal, let's get the component. So remember, we've instantiated an explosion system. We've instantiated a particle system here. So there will be a explosion system available using get component. So get component particle system. And we want to get the particles from it. So the particles are of type particle system dot particle. Now it's going to be an array that's returned. We'll call that just particles. will equal the explosion system. No, it won't. It'll be a new particle system.particle, and the size of it will be, what will the size of it be? It'll be equal to the maximum number of particles of the explosion system. So you go explosion system dot main dot max particles. Yes, that's the size of our particles array. Now, explosion system, to get the total number of particles, well, this is actually the number of particles that are alive. So number of parasites, number of particles alive, number of particles alive will equal the explosion system. Do we have a get particles? Yes, we do. Get particles. Now, get particles, as you can see there, returns an int, so that's the number of particles, and it takes a particles array as a parameter. So we'll put in our particles array, and it will populate the particles array by doing this. I know it's not very well designed, but this is what we've been dealt with. So number of particles alive will equal the explosion system dot get particles particles. We can now loop through each of those particles. So let's set up a for loop. So int I equals 0, I is less than the number of particles alive, and I plus plus. And for each particle, so for particles, now the current particle, for each particle, we want to set its color. So let's just type color. There's only one color available, and that's start color, and that's exactly what we want to set. So start color will equal, just for the time being, let's just set a fixed color, say blue, just to see if this is working or not. So on the late update call, it'll do this. It'll cycle through each particle and set it to blue. Remember, at the end of this, we don't want to keep running this every time. So let's change that. Let's change exploding to false. So it'll run this once, set all the color, and then it'll consider itself done, and it will never call this again. Let's try. Go away. So there's our object. Smash the... Okay, we've got an error. No worries. The error is there is no particle system attached to the player game object, but a script is trying to access it. Okay. So get component particle instantiate. Oh, I see. We need to create an object, because this instantiate method returns an object, a game object. So what we can do is just set up a object up here, private, it'll be a particle system, we'll keep it consistent. Well, this is the actual object, so we'll go explosion system. So we don't need to declare it there. And this will be, sorry, I'm going a bit fast here. So explosion system, we're still going to get the component, but we need to hang on to it as such. So we'll go explosion system will equal instantiate blah blah blah. Let's try that, and hopefully that will sort out this mess here. Oh, I cannot convert type. Right, the type here, instantiate, is returning a game object. We want a particle system. The reason is because prefab explosion is a game object. We should change prefab explosion to be a particle system. So let's redeclare that as a particle system, a public particle system. Prefab explosion, let's go wire it up. Let me just redo that just to make sure it's working. Okay, so explosion particle system. Yes. So you need to make sure that particle system is in brackets there. Right, let's go back to our script. So we've got our particle system is a prefab explosion. Sorry, our prefab explosion is a particle system. So that should fix up that part. I just noticed one more problem. I guess we don't need this. Let's just delete that line. Explosion system equals get component. We don't really need that, I think. It's being instantiated correctly, I think. You notice when we go to the late update, we're exploding, and then we set the color and we change it to exploding equals false. Now, as soon as exploding equals false occurs, in our regular update, this will start happening again. Our player will start moving again, which is not what we want, and that in turn will set off more collisions, setting off more explosions. So that's not the right way we should be doing that. We should think of another flag to use. Let's just use the flag alive. So if we're alive, we will move forward. So let's put that as a boolean here. If and when we start the game, we are alive. So let's set that to true. So when we start the game, we are alive. If we are alive, move forward. Great. When are we not alive? Well, when we explode. When we explode, we are no longer alive. We are dead. Where alive equals false. Exploding equals true. Destroy the object player and instantiate the explosion system. Good. So only when we're exploding will we set all the colors. We'll immediately set exploding to false so it doesn't run that a second time. And because we're still not alive, we will not move forward, and no more collisions will be called. Let's give that a go. 5th time lucky. Great. We have no errors. Here's our explosion. And the player is, well, the player parent is still there. Let's do it one more time. The only issue is that nothing has changed. The color of the particle is the same, isn't it? Still orange. I think I know the issue. It's because we've created a particles array. We've set all their color to blue, but we have not reset the particle system's particles, if you know what I mean. So explosion system dot set particles. Yes, this is important. An important step that I forgot. We have to set the particles of the explosion system back as, so here's what it takes. Set particles takes an array of particles and the size. So the particles is just our particles array, and the size is the number of particles alive. Hopefully all the particles will be blue when we strike the wall. No, of course not. Right, the problem is with our shader. Now, shaders are a bit of a tricky thing. So, but luckily there's not much we have to change, okay? So instead of using this material, see our explosion material is just using a regular shader, like a legacy shader, right? We need to allow Unity to change the start color. So if we go back to our explosion prefab, see that it's got a start color here? We want the explosion material to be based off that start color. Now, in order for that to happen, we have to create a custom shader. It's a little bit complicated, and I wish there was an easier way, but I haven't found it yet. So just bear with me. Go to Materials, right click and create a new shader just a standard surface shader is fine. We'll call that explosion. Right, so we've got this explosion shader. And double click on that. Now it looks complicated. When this opens up, it looks quite complicated, but we can ignore most of it. So yeah, shaders are a kind of a complicated thing. Now there's only one thing we need to, well, two things we need to do. Under this structure input, we just want to create another float. I'll just have to reference what I've done. Okay, it's going to be a float 4. Don't ask me about the details. I'm not great with this. And we'll just call it a vertex color. Okay, so vertex color, and it's a type color. Right. And then just under here, how we've got a fixed for C equals something. Well, we want to multiply that C. So C times equals, so we're going to multiply itself by the vertex color. Right? Let me just consult my little, sorry. Yeah, not by the vertex color. We're going to multiply it by the inputs vertex color. So remember there's an input here, and inside this structure we've got something called a vertex color. Now at this step we want to multiply C times equals the inputs vertex color. All this does is allow us to use that start color in our material or in our shader or whatever. Okay, that's done. Let's go back to here. Now, can we set a custom shader here? From what's this custom here? Oh, no. Maybe the shader here we have to change. There we go. So under your explosion material, so the orange material, go to shader, and we're going to change that to custom, and it's going to be an explosion. Custom explosion. And leave everything else the same. So it does everything we've wanted it to do. You can set its color, except that it will be able to take this start color that we're setting in code and apply it to the material. I hope. Just to confirm our player. So yes, we're going through all of that. Particles start color. Color blue. The system, we're setting its particles. Yep. And hopefully the shader will handle the rest. Let's give it a go. It's different. It's not orange, so I'm happy. Let's revisit what we're doing here. So explosion. Yep, that's fine. We got these materials. Okay, the issue is that the color of our material for our explosion, so material for our explosion, the shader is fine, is orange. When we're applying the blue and using that shader code, it's mixing the orange with the blue and creating a nice dark black for us. So change that to white. We don't want any interference. So change the explosion material color to white. So it's still using the custom explosion shader, but now it's white. Give that a go. Great. Blue. We don't want just blue, do we? We want a random color based on the color of our model. So our model's that. So let's make a let's put a just under the constants here, let's make a private, it won't be constant because it's going to be an array, so we'll say a read-only, a private read-only color 32, we'll use color 32 array called, we can just call it colors, I think, colors, however you wish to spell it, and that'll be equal to a new, well, we don't even need to declare new, we can just say what it is equal to. It's going to be color red. If you want to get technical about this, you could go into MagicaVoxel, use this button here to select what color, so that's a red, and click on this HSV down the bottom, and that'll tell you the actual code. So let's do it precisely. So that color, so remember you click on this button here, it's pick the voxel color. Click on the section, so it's actually not red, it's not pure red anyway, it's 23800. So back in our code, let's do a new color 32, RGB, so R will be 23800. There is an alpha channel there, which has to be, if we want to see it, we should be 255. Just to make sure this is working, colors, yeah, that looks okay. So this is an array of colors. We're going to declare each color within here. So copy and paste that. New color 32. I'm using color 32 because it represents everything in RGB numbers, which is much easier for me to understand. If you just use color, well, it's a value between 0 and 1, and it's a bit less intuitive. So we'll put 4 of these, as there are 4 colors in our model. Right, the next color, use our color picker, is yellow. It's actually yellow, so 255255. It doesn't matter the order, it's because we're going to randomize what the colors are showing. 255255. Next color is blue. It's not really, it's kind of a, anyway, 0102, 0102 255, 0102 255, and the final color, so green, it's the middle value is 204, so 0204. Yeah, so we've got a colors array. So instead of just remember this colors array, I'm using it as a read-only array here, but for example in under over, I've got a set of characters, and each character is an object as such. It's a custom object, and each custom object has its own color array. So depending on the model, you'd set different colors. But just for this little tutorial, we're setting a standard color for our model, a fixed set of colors. Now, what do we want to assign? Well, let's assign a random color. We don't want to divide it up or anything, just set it randomly. So random dot we need to use our colors array, and what number do we want to use? Well, we want a random value from 0 to 3, right? Because the 1 2 3 4, and in arrays we start at 0, so we want to go up to 3. To do that, let's go random range. What does it take? It takes a minimum 0. Now the maximum, if we're using, I'm not going to hard code this, I'm just seeing what the range method takes 2 integers, a min and a max. And if you look down here, I can't move my mouse, but it says returns a random integer number between min inclusive and max exclusive. So it'll include 0, but will not include the final number. So it has to be bigger than, it would have to be 4. Simply, we could just go colors. So this is the colors array, colors.length. There we go. So colors.length will be 4, and that will work, I hope. So randomly pick a color from that array. Let's see what happens. Sorry, let's unpause it. So we've got green, blue, yellow, and red. Bang. Green, yellow, blue, and red. And that's it for this tutorial. Let's watch it one more time. If you have any questions, please post. I'm sure there's lots of questions. The shaders are quite difficult. Bang. We've got multiple colors. Yeah, okay, some of the particles are going in the wall. You could fix that up by offsetting where it's instantiated. So for example, here's where, in our player control, here's where the explosion system is being instantiated. It's being instantiated at the position of the character. So remembering our character, he's traveling in a Z. Sorry, that's not it. Yeah. Our character is traveling this way, which is modifying our Z position. So if we subtracted a little bit away from the Z position, we could make the explosion occur a little bit behind center or wherever it's being instantiated. Let's do that. Transform.position. Okay, so position is just a vector 3. So vector 3, new position will equal, oops. New position will equal new vector 3, which remember it's XYZ, so it'll be transform, it'll just be this, transform.position.x, we want to keep that the same, we want to keep y the same, it's just our z value, .z, let's, for argument's sake, add 0.5 to that, just to see what happens. And the explosion system will be instantiated at new position instead of this transform.position. So new position, rotations, that's fine. Let's give it a go. So it should be exploding a little bit behind the player or towards the back of the player. It's hard to see. So how about what if we make that 5.5? So that's going to definitely result in something, I assume. It's not, I don't want to add 0.5, I want to subtract 0.5 because we're going in a negative direction. Double negatives, yeah. Try that. Righto, that looks a bit better. Oh, well, you know, you can adjust that figure to your taste. Okay, thank you. Any questions, leave them for me. I'll try to get back to I'll try to answer everything. Cheers.